Today we will see the coordinate bond in a coordination chemistry. Hmm? The linkage which can join two atoms together in a molecule is called as a chemical bond. We know that we can form the molecules by joining different atoms with each other or different ions with each other. But during the joining of two atoms or ions, there is a formation of linkage can be take place. That linkage is known as a chemical bond. For the formation of such linkage, at least two electrons are required. On the basis of source of these two electrons, the chemical bonds are divided into different types such as covalent bond, ionic bond, metallic bond, coordinate bond. And on the basis of force of attraction by which two atoms or ions can join with each other, they are divided into two types known as a hydrogen bond and van der Waals force of attraction. But on the basis of electrons, the chemical bonds can be divided into four types, mainly basically on the four types known as a covalent bond, ionic bond, metallic bond and coordinate bond. In this video, we can discuss the coordinate bond. Then let us first see the definition of coordinate bond. A chemical bond which is formed by sharing of lone pair of electron between the two atoms, which is donated by one atom and accepted by other atom, is called as a coordinate bond. That means during the formation of chemical bond, we need two electrons. That two electrons, if donated by one atom and accepted by other atom, that means contributed by one atom wholly, then such bond is called as a coordinate bond. During this bond, the lone pair of electron is basically donated by the non-metal atom and accepted by the metal atom. That means the metal atom, which can contain at least one empty orbital, is able to accept the lone pair of electron. And the non-metal, which can contains greater than half electron configuration, contains at least one lone pair of electron. It is able to donate the lone pair of electron. Therefore, the coordinate bond is formed between the metal atom and non-metal atom. As we can see the characteristics of coordinate bond, generally the atom which can donate the lone pair of electron is called as a donor atom. It's always the non-metal atom. The atom which can accept the lone pair of electron is called as a acceptor atom. It may always the non-metals because it contains the empty orbital, therefore it can accept the lone pair of electron, hence it is called as a acceptor atom. During the formation of coordinate bond, the electron pair is donated from one atom to other atom. Hence, the combination is directional. That means from the non-metal atom to metal atom, the lone pair of electron is donated. Hence, it is called as a directional. Therefore, the coordinate bond is called as a directional bond or dative bond. Due to directional nature, the coordinate bond is always represented by the arrow pointing towards the acceptor atom from the donor atom. The covalent bond is denoted by the dash, the ionic bond is denoted by the dotted line, the metallic bond is denoted by the dotted line. Similarly, the coordinate bond is represented by the arrow pointing towards the acceptor atom from the donor atom. That means that arrow can donate, the atom can show the flow of lone pair of electron, that is flow from the non-metal atom to metal atom. During the formation of coordinate bond, there is a formation of the delta positive charge and delta negative charge. Because the lone pair of electron is transferred from, that means donated from donor atom to the acceptor atom. That means the donor atom can acquire slightly positive charge, the acceptor atom can acquire slightly negative charge. That means there is a creation of poles. Therefore, the coordinate bond is also called as a semi-polar bond. There is no transfer of electron. There is a sharing of electron. Therefore, it cannot be considered as a completely polar bond. Simply, there is called as a semi-polar bond due to creation of dipoles. After the formation of covalent bond, after the formation of coordinate bond, it is indistinguishable from the covalent bond. Because similar to the covalent bond, there is a overlapping of atomic orbital. Similar to the covalent bond, there is a sharing of lone pair of electron between the overlapping region. Therefore, it like similar to the covalent bond. Hence, we cannot distinguish the coordinate bond from the covalent bond after the formation of coordinate bond. Hence, the coordinate bond is also called as a coordinate covalent bond. We see the mechanism of formation of a coordinate bond. During the formation of coordinate bond, we can consider that suppose A atom can combine with a B atom and forms a coordinate bond, where A can act as a donor atom and B can act as a acceptor atom. That means A must be a non-metal atom and B must be a metal atom. During the formation of coordinate bonds, we can say the first step, the transfer of one electron from the donor atom to the acceptor atom can be take place. When an acceptor atom and donor atom can comes closer, there is a repulsion between the outer orbitals. That means the empty orbital and lone pair containing atomic orbitals. Due to that repulsion, the energy can be given out, and the energy that given out can be accepted by the lone pair of electron. And that lone pair of electron can show the vibrations, and during the vibration, the paired electrons get unpaired. That means the pairing energy can exceed the vibrational energy, and due to that, one electron can be rotate their spin and convert into parallel electron pair. And due to instability, out of one parallel electron, one electron can be transferred to the acceptor atom. During this transfer of electron, the cation is formed by the transfer of electron and anion is formed by the acceptor of electron. That means the metal atom can acquire the positive charge, negative charge, and the non-metal atom can acquire the positive charge. Because the proton cannot be transferred, only the electron can be transferred. Therefore, the positive charge on the A atom and negative charge on the B atom can be created. Hence, cation and anion can be formed. This step is called as a transfer of electron because we can transfer the electron from one atom to other atom. In the second state, that two atoms can collaborate with each other. During the collaboration, the atomic orbitals containing single electrons can overlap with each other, and again there is a formation of pair of electron can be take place. Because during the overlapping of atomic orbitals, they can utilize the energy, and during the utilization of energy, due to the attraction force, the energy can be lowered, and due to lowering of energy, again that electron can rotate their spin and convert into pair of electron. And that pair of electron can be shared in the overlapping region, and therefore we can say that there is a formation of covalent bond can be take place. In the coordinate bond, there is a joint effect of ionic and covalent bond. That means in the first step, there is a formation of positive charge and negative charge. They can come closer due to electrostatic force of attraction, therefore there is a formation of ionic bond. In the second step, there is a sharing of pair of electron, and in the overlapping region, that electron can be shared, therefore there is a formation of covalent bond. Hence, we can say that the coordinate bond is a joint effect of ionic bond and covalent bond. Therefore, coordinate bond is called as a double bond or semi-polar bond. Double bond or a semi-polar bond. Okay, there is a mechanism of formation of coordinate bond. Let us explain with example how the coordinate bond can be formed, like NH3BF3 adduct. During the explanation of this formation of coordinate bond, we first identify the donor atom, and then we have to identify the acceptor atom. In NH3BF3 molecule or adduct, there is two molecules which are joined with each other by the coordinate bond. That is ammonia molecule and boron trifluoride molecule. First, we will see the boron trifluoride molecule. In the boron trifluoride molecule, the central atom is boron, whose atomic number is 5, and the electronic configuration is 1s2, 2s2, 2p1. That means during the formation of BF3 molecule, the one electron from the boron atom of S2s orbital is shifted to 2p orbital, and there is a creation of 3 unpaired electrons. After the creation of 3 unpaired electrons, the 4 orbitals, 1s orbital and 3p orbital containing 3 unpaired electrons can mix with each other by the sp3 hybridization. And in the BF3 molecule, boron can form sp3 hybrid orbitals, 4 sp3 hybrid orbitals. Out of 4 sp3 hybrid orbital, 3 contains unpaired electrons and 4th is empty. Therefore, the 4th empty orbital is available for acceptance of electron. Hence, we can say that boron can act as an acceptor atom. Now see the NH3 molecule. In the NH3 molecule, the central atom is nitrogen, whose atomic number is 7, and the electronic configuration is 1s2, 2s2, 2p3. During the formation of NH3 molecule from the nitrogen, there is no any possibility of excitation of electron, because after the 2p orbital, the empty orbital is not available. Therefore, from the electron from the 2s orbital remains as it is and forms sp3 hybridization. They can form 4 sp3 hybrid orbitals, out of which one contains lone pair of electron and 3 contains the bond pair of electron. That means unpaired electron which can forms a bond with the hydrogen atom. After the formation of NH3 molecule, there is a lone pair of electron on nitrogen atom. It may be donable, therefore nitrogen can act as a donor atom. Hence, from the BF3 molecule, boron can act as an acceptor atom, and from the NH3 molecule, nitrogen can act as a donor atom. Therefore, if these two atoms comes closer, that means two molecules comes closer, nitrogen can donate the lone pair of electron to the empty orbital of boron and forms a coordinate bond. We can show that by the arrow. In the direction nitrogen to boron, there is a sharing of electron. An arrow, we can show the arrow from nitrogen to boron. That means the lone pair of electron can be shared from nitrogen to boron. Similarly, we can see another example. There is a formation of ammonium ion. During the formation of ammonium ion, ammonia molecule can react with the proton. Here, the ammonia, we can already seen the formation of NH3 molecule. In the formation of NH3 molecule, we can say that nitrogen can contains one lone pair of electron. Therefore, it can act as a donor atom. Now see the proton atom. During the formation of proton, the hydrogen atom can lose one electron and forms the empty 1s orbital. That means it is a contain empty orbital, that therefore it can easily accept the lone pair of electron. That means the proton can act as an acceptor atom, nitrogen can act as a donor atom. If the two combines with each other, the nitrogen can donate the lone pair of electron to the 1s atomic orbital of the proton. Hence, there is a formation of coordinate bond can be take place in the ammonium molecule. That is, nitrogen of the ammonia can share lone pair of electron to the proton and forms a ammonium ion, where ammonia and hydrogen can form a coordinate bond. Thank you.